Okay, so we have a motorboat that can go 24 miles in 2 hours downstream going with the current, whereas upstream going against the current it takes 4 hours to go that same distance, 24 miles. So the question is, how fast can the motorboat go? What's its speed with no current? And what was the current speed? So again, as usual with word problems, we start by making variables that stand for the quantities we're looking for. So let's let R equal the speed of the motorboat without the current. And let's let C be the speed of the current. Okay, now we can start writing equations using R and C. So we know that rate times time is equal to the distance. Rate times time is equal to distance. So the speed of the boat going downstream, going with the current, is R plus the speed of the current. So that's the speed of the boat in still water without a current plus the speed of the current. That's how fast he's going downstream. And it's for the time of 2 hours, so t, the time will be 2. The distance is equal to 24 miles. So that's simply taking the formula rate times time equals distance and plugging in the speed of the boat going with the current. So you're adding the current speed to the speed of the boat without the current, going for 2 hours, and that product should be 24 miles then. Now we're going the other way. Upstream is against the current. So the speed of the boat without the current, and you take away the speed of the current because it's fighting against you. So you're going not as fast, whereas with the current you're going faster. Against the current you're going slower. Instead of 2 hours now, it took 4 hours to go the same distance, the distance 24 miles. So right away we have two equations, and notice if I divide by 2 on both sides of that equation and divide by 4 on both sides of the second equation, we end up with something really nice. Now, dividing the left side by 2 just cancels the 2 and it leaves R plus C. The 2's simply cancel. It's a common factor. It's a factor because the numerator is that times 2, the denominator is 2, the 2's cancel. And 24 divided by 2 is 12. The second equation, when we divide by 4, the 4 cancels, so you're left with R minus C on the left side. And 4 divides into 24 6 times. So now we have two nice equations. We can solve it by simply adding them at this point, which eliminates the C. R plus R is 2R, so 2R equals 12 plus 6 is 18. And dividing by 2 on both sides, we end up with R. The speed of the boat in still water is 9 miles per hour. The unit here is miles per hour. Miles divided by hours. Miles per hour. Okay, that's the speed of the boat in still water, but what's the speed of the current C? We can use any of the earlier equations to find C. This looks like the best one to use, the simplest one. So using this equation, along with this result we just found, we then know that R plus C is 9 plus C is 12. Take away 9 from both sides, and you find that C, the speed of the current, is 12 take away 9 is 3. And that's miles per hour. So the current is going at 3 miles per hour, and the motorboat could go 9 miles per hour with no current.